Try this problem on your own, so please press pause. First, I'm going to simplify within the parentheses. That's the way I'm going to approach the problem. I could multiply this by each index here. Remember, this is to the 1 power, to the 1 power. But I'm not going to. I think it's easier to simplify within first. So what I did was found a common denominator, and I moved this y to the negative 2/3 to the numerator. I found the inverse, in other words. And I found a common denominator with the x's and the y's. So now it's as simple as subtracting and adding fractions. I'm going to subtract these because I'm dividing indices and my bases are the same. I'm going to add these because I'm multiplying and the bases are the same. And now I'm going to use the power rule. But actually, instead of using the power rule now, I'm going to change these. So the 8's going to go up to the numerator. The 27x to the 16 y to the 17/3 is going to go to the denominator, and I'm going to make this positive. I think that's probably the easiest approach. Okay, so now I'm going to go ahead and apply the power rule. Bear in mind that the index there is a 1. And there's the final answer. Okay, here's an interesting one. Right now, this is in radical form. Well, we want to put this into index form. So in order to do that, that is going to be the denominator, and that is the numerator, as we learned in the past. So I'm going to go ahead and put this in index form. Get the 3rd, b to the 12th. Okay, to the 3/4 over 3. Now, can we go ahead and divide the 81 by the 3 now? No, we cannot, because this is in the radical still. It's just written as a different form, and that's actually not 81. That's the 4th root of 81 to the 3rd power. So in other words, that is 20, well, not in other words, but which means that it's 27, because the 4th root of 81 is 3, and then 3 raised to the 3rd power is 27. Okay, now for these others, I'm just going to use a power rule. So that's going to be a to the 9 over 4. A to the 9 over 4. And that's going to be b to the 9, because I'm just multiplying those fractions, over 3. And one more step is divide the 27 by the 3. So we've got 9a to the 9/4, b to the 9th. b to the 9, rather. Finished. Try this one on your own. Please pause it. I don't think it's very challenging. It looks challenging at first. Now I'm going to go ahead and solve it. And I'm going to simplify the bottom first. In fact, I'm going to do it all at once because the bell's going to ring and class is going to start and I have to complete this video by then. So I'm going to simplify. I'm simplifying this, okay? So this is a fraction. So 6/15, that's equal to 2/5 a squared b to the 3rd. And then I'm going to use the power rule here. The square root of 64 is 8, and that's a to the 3/4. And that's b to the 2/10. Okay, so this is, here, let me rewrite this so it's clearer. So what this is a division problem. We're dividing fractions, a to the 3/4, b to the 1/5. I just reduced it, or simplified it, over 1, divided by 2a to the 3rd, 2a squared b to the 3rd over 5. So I'm going to multiply by the inverse. When we divide fractions, we multiply by the inverse. Okay, and now we just have to clean it up. We're going to multiply and cancel and make it look prettier. And in essence, we're simplifying it. I'm sorry that it's bouncing. This tripod is kind of cheap. I got it off Shopee, but 5 times 8 is 40. And I'm just going to write these. B to the 1/5 over 2a squared, b to the 3rd. Okay, so 40 divided by 2 is 20. Okay, so that is 8/4. So that means on the bottom it's 8 to the 5/4. And that's b to the 15 over 5, so b to the 14 over 5. Okay, we're finished. There's actually more that I should do to it, which is called rationalizing the denominator, but we're not going to worry about that for now.